In this video, we're going to be taking a look at Investigation 2, more specifically just 2.1, sharing pizza. So think about everything that we've done so far. Looking at Investigation 1, we've learned to compare quantities using these methods. We've used, ratios, fractions, percents, and differences. So we're going to be doing the same thing, but again, we're going to enrich the understanding of our characters or of the concepts that we've been studying in this section. So in order to understand what we're going to be doing, let's look at the problem. So here we have a dining room. It's at, this is a dining room at a camp. Large table seats 10 people. So there are 10 people here. And then you have the small table, which seats 8 people. When the campers come for dinner one night, there are 4 pizzas at the large, so there are 4 pizzas here. And over here, there are 3 pizzas at the smaller table. Makes sense? Okay, so we're doing everything from this particular, in this section, or in this problem, 2.1, we're looking at these tables. So when we answer these questions down here, we're looking at those tables. So in part A, it says the campers at each table share the pizzas equally. Say, so the people at the large table with the 4 pizzas, they share equally, and the table with the 3 pizzas and 8 people, they share equally. Does a person sitting at a small table get the same amount of pizza as a person sitting at the large table? So they cannot share from large table to small table or small table to large table. They cannot share. So answer this question and then explain your reasoning and come back to the video to see how you did. Okay, so here we have a diagram, large table to small table. Okay, so let's compare. So the large table has 4 pizzas for 10 people. And the small table has 3 pizzas for 8 people. In your notes for part A, it might be good to have this diagram in there. Just sketch a quick tables with the pizzas, whatever, so you can have a visual understanding of what's going on. So now to figure out who gets more, it's easiest to answer this question if we have the same amount of people at the tables. And again, we're not really going to put the same amount of people, but it's easier to compare fractions if the denominators are the same. So, okay, think about 10 and 8. What is the least common multiple of 10 and 8? Right, 40. And so we're going to make it so that there's 40 people at each table, using the ratios of 4 pizzas to 10 people at the large table and 3 pizzas to 8 people at the small table. So now let's figure out, okay, if the large table had 40 people, how many pizzas would they get? Well, I multiplied by 4 to go from 10 to 40 here, and so I would do the same thing up here. And they would get, at the large table, we would get 16 pizzas to 40 people. And at the small table, here I multiplied by 5, so I would do the same thing up here. 3 times 5 is 15. So if there were 40 people at the small table, the table would get 15 pizzas. So now you can look to see, whoa, hey, the large table, this ratio 4 to 10 is a little bit bigger than the ratio of 3 to 8 because we changed them to equivalent fractions, and now they're easier to compare since they have the same denominators, right? So the large table is going to receive a little bit more pizza than the small table overall per person. Now let's take a look at part B. Selena wonders whether a person at a small table or a person at a large table gets more pizza. She uses 2 ratios. 8 to 3 and 10 to 4. So those are very similar to the ratios that we used just now. The only difference is 8 to 3, we use 3 to 8. So she compares the number of people, so that represents how many people at the table, and that represents how many pizzas. So we used 3 to 8, where she is using 8 to 3, which is fine. right? There's nothing wrong with that. But let's say this is her understanding, and this is kind of how she gets her answer. She says the difference of 10 and 4 is 6. So she's looking at the difference between the number of pizza and the number of people at the table. That difference is 6. And then the difference of 8 and 3 is 5. The large table has more pizza, so has more people, so the people at the small table will get more pizza. Right? Do you agree with her statement? Do you not agree with her statement? Answer that question and then come back to the video. Okay. So no, we can't agree with that, because the difference between the number of people and the number of pizzas, there's really, when we're comparing who gets more, there's no mathematical significance in that difference. It tells us a little bit, it gives us maybe an idea, but it doesn't tell us, that difference doesn't tell us much of anything. Okay, just because there's a less of a difference between the number of people and the number of pizzas, that doesn't really tell us anything. Now let's take a look at number 2. So Tony disagrees, which rightfully he should. Okay, and then Tony says this: if you place 5 pizza at the large table and 3 pizzas on the small table, Selena's method will show that the campers at the large table and the campers at the small table will get the same amount. So that would look something like this. If 10 people share 5 pizzas, however, each person gets 1/2 of a pizza. So that's what this is. That's more pizza than each of the 8 people who share and get 3 pizzas, or who share 3 pizzas will get. Do you agree with his statement or disagree with his statement? Answer that question and come back to the video. All right, so you should agree with him, because this is 1/2, which is 50%, right? So each person will get 50% of a pizza, and this is less than 40%. It's like about 37%. At the smaller table, each person will get 37%. However, using Selena's logic, right, they should get the same, because this difference from 10 to 5 is 5, and this difference between 3 and 8 is 5. And so that disproves Selena's understanding of the numbers that she used, right? She looked at the differences between how many people were at the table and the number of pizzas, right, which has no significance or very little significance in what we're doing here. Now let's take a look at part C. There are 160 campers. If everyone sits at the small tables, how many pizzas should the camp director order? Go ahead. Let's go. I'll have you go ahead and answer all of these. Now I'm going to give you a hint, right? So we're using the same ratios that we used previously, which would be these ratios here. So when we're answering these questions, we're using 4 pizzas to 10 people at the large table and 3 pizzas to 8 people at the small table. So go ahead and answer part C, 1 through 4, and then come back to the video to see how you did. Okay, so let's take a look at number 1. It says if everyone sits at the small tables. So on number 1, let me do this. Everyone sits at small tables. How many pizzas should the camp director order? Now remember, this is for 160 campers. And so if we're at the small table, which has a ratio of 3 pizzas to 8 people, and there are 160, so we're planning a meal for 160 campers. If I could spell P-E-O-P-L-E, how many pizzas should we order? All right, so we have our equivalent ratios, so we can cross multiply. So I'm going to strip away pizzas and people, and we're just going to look at 3/8 is equal to x over 160. All right, so then we can cross multiply, take our cross products there. So you'd have 3 times 160 is equal to 8x. We're going to divide out that 8 to get rid of it over here. And when you do that, 8 will go into 160. Well, 8 goes into 16 twice. So it'll go 160 20 times. And so 3 times 20, that gives us 60. So we would want to order 60 pizzas for that amount of people to make sure each person gets enough according to the ratios of the large table, which is 4 pizzas to 10 people. Then on number 2, it says if everyone sits... Oh, sorry, no. That was the small pizzas question. Number 1 was using the ratios of 3 pizzas to 8 people. Now number 2 says we want to use the ratio of 4 pizzas to 10 people because our camp only has large tables, and so we have to use those same this ratio right there. So on number 2, we're using 4 to 10, and we want to know for 160 people how many pizzas should we order. So we set up just like this, and then we cross multiply, so it'd be 4 times 160 is equal to 10x. So we're going to divide out that 10 here. And when you divide out a 10, that turns into 1, and then that's 16. So 4 times 16, that's 64. So we should order 64 pizzas using the ratio of 4 pizzas to 10 people because our camp only has tables that can fit 10 people. We don't have tables that can fit 8 people. Then on number 3, it says the camp director also has extra large tables that seat 25. How many pizzas should be placed on each of these tables? So now to answer actually 3 and 4, make a choice. Either you're going to use this ratio or this ratio. Okay, I'm going to do both of them, but let's take a look on number 3. So let's say you used 4 pizzas to 10 people. Now, if you have a table of 25, right, we cross multiply, so that would be 10x is equal to 4 times 25. Divide that by 10, and you get x is equal to, in this case, 64. That's not right. Sorry, that's just simply 10. I was looking at the wrong numbers here. So that's just 10 pizzas. So if you're using the ratio of 4 pizzas for 10 people and you have tables of 25, for the tables of 25, you are going to order 10 pizzas for those tables of 25. However, if you used 3 pizzas to 8 people, and you're looking at using that same ratio for tables of 25, then you would set up your proportion like this, and you would have 8x is equal to 25 times 3, divide by 8 to figure out what that x value is, and in this case you would get 9, I'm going to round that one to 9.35 pizzas. Right, so around 9. You can't order 0.35 pizzas, so we're going to say 9. That rounds down to 9 pizzas. Okay, so on number 3, whichever one you ordered, or whichever ratio you used, if you used the 4 to 10, you would get 10 pizzas per table. 3 to 8, you would get more like 9 pizzas per table. And then on number 4, it says how many pizzas should he order if everyone sits at extra large tables? So this is for all 160 campers. So it's saying if everybody sits at those extra large tables of 25, then we're going to do this one twice as well. So we're going to use this ratio of 10 to 25 for 160 people and figure out how many pizzas we would order. So when we do that, you would have 10 times 160 is equal to 25x. So to get rid of that 25, you divide that over, because remember, we want to figure out what number times 25 will give us 10 times 160. So we ask the inverse question, 10 times 160 divided by 25 gives us what number? And so when we multiply 10 times 160 and divide by 25, you would get 64. All right, so for this ratio, using the 10 to 25, you would order 64 pizzas. And now, if we use the ratio of 9 to 25, 9 pizzas for every 25 kiddos at the camp, we're planning for 160 kiddos. Then we would cross multiply. 25x is equal to 9 times 160. So we would divide out that 25, not the 9. And you would get x, so that's gone from over there. So you would get x is equal to 59.84 or 60 pizzas. So if you have campers that are more likely to eat 9 pizzas per 25 kids, then you would get 60 pizzas. But if they're eating 10 for every 25 kids, you would order 64. Okay, that is all that I have for 2.1 sharing pizza comparison strategies.